Merike Kaeo. She is the Chief Technology Officer with Farsight Security, Inc. She'll be talking about security. So from interoperability, we're going to security. And specifically, she's going to be talking about ascertaining what is abnormal to detect what is potential malicious behavior. Welcome, Ms. Kaeo.
Thanks, Leah. And I'm so happy that Aaron asked that question because I have some answers that I will be talking about in this presentation. So the goals for today, right? I mean, everything is going to connect to everything and everything is going to talk to every little thing that we have, right? The blinds, the Wi-Fi. And by the way, I like the symmetry of these Wi-Fi. I always try to look, where are they, right? But so what is the new normal for today? What are the traffic patterns? Because from a security perspective, it's all about knowing who's communicating to whom and what are they trying to do. Don't have security as an afterthought. Security is always an afterthought. Okay, I've been in the industry for 25 years. Security is always an afterthought. We have to stop that. And we have to start building requirements, security requirements into products, into devices before they get implemented and built and shipped. Now, I've been doing security for about 20 years. I started off my career building the FDDI backbone at the National Institute of Health in the late 80s, early 90s, and I've been an Internet Society member since 1992 when it got started. And so one of the things that I really never looked at when I was building networks and when I started with security was DNS. And it was probably about, I don't know, 8 or 9 years ago, I started doing a lot of security assessments. And I started realizing that, you know, in some of the communities that I was in, how much DNS was utilized for malicious activity. And whenever I asked people, so, you know, who is your registrar and what are you doing with DNS? People are like, I don't know, those are the DNS people. So the security people really never paid attention to DNS. And it's been really interesting how in the last 5 years, people have come to understand that this is actually extremely important when you're trying to determine malicious activity. And the bad actors, by the way, have also discovered that DNS is a really useful tool for them. So I want to talk a little bit about observable behavior, specifically in DNS, that can be utilized to help with overall security, and then determining, you know, what is actually abnormal in this environment where everybody's talking to everything and using a bunch of different protocols. And then how do we continue to evolve, right? A lot of evolution is necessary. We all have job security for many, many lifetimes. So the obligatory picture of everything connected to everything, right? So you've got your things that are connected and utilizing, you know, any kind of protocols, ZigBee, you know, TCP/IP, whatever is out there. You've got the fundamental infrastructure, and then you've got your application interfaces. And I have to tell you, me too, I download apps like crazy. But my favorite latest one is the one where I can pay with my phone for parking. I am Estonian. I've been doing that in Estonia for 10 years. Now in Seattle, I can do it. But depending on where I am in Seattle, I have to use a different app. That's kind of a bummer. So the new normal. Right? The new normal is that we're launching satellites so that, you know, everything can communicate to everything. So you're going to have, you know, traffic bouncing around the earth up and down, right? So we can talk to, you know, things can talk to things. Our homes are extremely networked. I'll have some pictures of my home. I don't really talk about it too much, but yeah, I like to play with things. And so, you know, there's ad hoc mesh networks. There's a prevalent use of tunneled protocols, right? And this, from a security perspective, is an issue. And there's an app for that, right? I want an app to turn the microphone on. Why not? So when we're talking about security, right, to me it always comes to 5 fundamental principles. The first one is authentication. Who or what are you? And, you know, what ties together with that also is credentials, credential management. And we are at the infancy of being to understand credential management. And I say this because I actually have a spreadsheet that I keep with all my passwords that I keep in my safety deposit box, and I have at least 180 of them. Because every time I have to shop, every time I'm logging into an airline or a hotel or whatever it is, plus all my work stuff, right? There's a credential that's required, right? And two-factor for everything, not good enough, right? I don't want to think about, hey, I want to now, log in and, book my flight. I don't want to have to remember what the heck that PIN or that password or whatever it is, because I am supposed to have a different one in case one gets popped so it can't be used somewhere else, right? We have to work on new technology for that. That is coming. But authentication is really important for every single device because you want to know who are you communicating with, or from an application level, what application is trying to communicate with what application, and are they allowed to do that, which is the second point that ties into authentication, which is the authorization. Right, so authentication and authorization are absolutely critical for every single device out there. Integrity is also extremely critical. I have always been a proponent that you should have integrity for every single communication because I want to be absolutely ensured that there's cryptographic protection, that nobody has tampered with the data that I'm trying to send to you. The confidentiality piece, right, and that also ties in sort of with privacy because you want to make sure that only an authorized person can see the data, that is a policy decision. That doesn't have to be ubiquitous everywhere, and it can't be because there's some regulatory requirements, especially in the financial industry and other areas, where you're mandated to be able to see traffic in certain areas. Okay, it's a policy decision. I do believe in confidentiality and privacy, but it will not be ubiquitous everywhere. I think, in my mind, integrity is much, much, much more important. And then availability, also very critical, right? You want to make sure that what you're trying to access, you have access to. And so you have to think about protection in terms of denial of service or anything else that can potentially take the service down. Or if you're relying on the cell phone for something, what happens if you're in an area that doesn't have cell coverage? Right? You have to think through all these things. But when it comes to every single device and any kind of minimal guideline, I always say that we should at least have a 3-pager that points to existing standards. Okay, in the IETF, you have LOPAN, and Bluetooth came up with how you do fundamental security. These things exist. We should not create something new. We should look at what exists, come to a common ground in terms of this is the minimal requirement for all devices, and then move on. So privacy. The biggest concern, right, is how is the data collected? Who's analyzing it? How is it analyzed? Who's using it? And then how is it protected? Right? Especially if it's something that I consider confidential or private to me. And of course, there's a potential for increased surveillance and tracking. And I very much like the ISOC paper because it did point all of this out. But one of my questions, because I deal very much with information exchange from a security perspective, and we're not allowed to exchange information here or there because of liability issues and concerns. And I started thinking, well, is privacy changing? To me, the answer is absolutely. And so in this world where there's so much communication, and if I'm talking to a 20 or 25-year-old, they don't really care about what they're sending out because their view of privacy is much different than mine. So I think part of what we have to really think about is, what is privacy in this day and age of sharing information with a lot of people and really caring more about the availability of devices and being able to, turn my light bulb on with my app or being able to park with my phone, right? So how is privacy actually changing? So I do play with things at home, and a couple months ago I bought a new TV. And you know what my decision factor was? It's true, people laugh at me, my friends always roll their eyeballs. It could do IPv6. I was so psyched. Yeah, the user interface I'm not going to show you because I actually was at the store and I'm like, hey, which one can do IPv6? And sales guy's like, huh? And so I'm like, okay, let's look at the interfaces, right? And so the configuration, if you know IPv6, was fascinating. It was either you could do it automatically, but then I looked at the manual and it just says enter IPv6 address, line. And so the store, guy was like, and I'm like, just enter these numbers, 2001 colon DB8, blah, 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 right? Because I do the right thing, the documentation address. And he's like, I'm supposed to be the expert. And I'm like, yeah, what do you do? So anyway, cool TV, right? One problem, we were talking about updates. I turned it on a couple of times. Well, let me show the next slide. So I bought it because of IPv6. It came and got installed, and I'm clicking through things, and I'm going, oh no, didn't think about that. It's an Android device. So I haven't yet gone through all of the defaults, right, to figure out what I'm going to change. But I'm just going to point out a couple of things. Location information was on by default. I will turn that off. I do not like that. And another thing, right, it says that, update component usage statistics to whom? And there's a couple of other lines in there. And it's sending, I think, or wanting to send information to entities that I have no idea what they're going to do with that information. And so at some point in my copious spare time, I'm going to actually put on Wireshark, right, and, take a look at, okay, what's it trying to do to whom and what? Because I really want to understand this. And yeah, I probably actually will do this. And I think as a community, some of us should do this, because that way, for like the folks in the Consumer Electronics Show and all that, we have to convene the right people to say, nope, or somehow have transparency, so there's an easier way for the normal user, I'm not a normal user, right, to actually, turn off and make the decisions as to who is allowed to have what information. I will also point out that this TV does actually do updates, okay? I've had to do 3 updates in the 2 months that I've had it. One little problem. It tells you that it may take up to 30 minutes, and it does take that long. And so I don't watch a lot of TV, I don't care. I'll just say, yep, do the update. I'm not sure how many normal users will, be waiting for that 30 minutes. So just a little point. And then this is cool. I also was part of the Kickstarter program for LIFX light bulbs back in 2014. So I bought 8 of them. I'm like, oh, cool, I want to play with this. And then October 13th, I get this email, which tell me that, hey, get more from your LIFX, do an upgrade. And it even tells me improvements, faster Wi-Fi connection, more responsive, improved color output, security improvements, and bug fixes. Well, this is October 2014. What happened May 2014? Heartbleed, right? And so my only pet peeve with this is that I would like to have a button that says, what are some of the fixes, right? Maybe even in layman terms. Because as I was building this presentation, I'm like, let me look, because I've had 3 upgrades for my light bulbs. It's awesome. I love it. But as a security person, I love it. But, right, I don't know what was fixed. And so, again, there's a transparency issue here. And so I don't know, I don't know what the right middle ground here is. But for people that may want to know, right, I would rather be able to get that information somewhere. As I did a quick search through the LIFX site, I couldn't find details on what the security fixes were for the different times that I've had to do upgrades. So, but I'm happy that they actually do them, because I think they're doing the right thing, but I don't really know. So how do we detect anomalous behavior, right? I mean, in my house, yep, I've got other fun toys, shall we say. I bought a dryer a year ago because, it did let me control it with Wi-Fi. Have I played with that yet? No, I'll be honest, no. But the capability is there, and that is cool. And so, but I'm looking at my home, right? And I'm looking at, all right, I want to know who's communicating to what. I have a Sonos system, right? They've got their own little, communication protocol, but it just works. Of course, I had to tweak my firewalls a little bit. I didn't quite like that because I'm pretty stringent. But again, it just works. Now, my concern is I don't have as much time as I used to look at the traffic and what's going where. And things are open, things are being communicated, not always in encrypted fashion. So who's out there, right, maybe in the condo building that I'm living at, and just doing some reconnaissance. I have no idea, right? And then if some of my devices are infected, how do I know? Right? I mean, that is the biggest worry for me with the Internet of Things. I have no idea whether or not some of my devices are actually part of a larger scale botnet that are doing some kind of DDoS to somebody, maybe to even a government entity or, who knows who. So one of the things that is not as much understood as it should be is the fact that DNS is fundamentally used in many things. And so the previous speaker was talking about unifying protocols. DNS is such a protocol. And so when you think about it, right, humans think in names, machines think in numbers. So if I'm using my phone and I want to see what's on Netflix, right, I mean, I type in www.netflix.com, and then my wireless router, gives me the numbers that my phone needs to then go to Netflix, right, the IP address, basically. And really, I mean, DNS is ubiquitously used. So a couple of years ago, there was a botnet called DNS Changer, also called GhostClick. And what would happen is that they were very clever. This criminal unit, and I hate to say, but they were from Estonia, but they got caught. I know, gotta admit that, but. So what they did was they actually changed the recursive DNS resolvers so that queries would go to their specific network where they could get then ad revenue. Right? It was a very clever scheme. The interesting thing was, like in your home, you have no idea that you're not going to the right site, right? Because there wasn't anything nefarious. It was more just, scamming ad money. And so it's quite interesting because, when you're looking at it, I mean, DNS is getting utilized for almost everything. And so when you're starting to pay attention, what DNS communication is going on, right, you can start analyzing some nefarious communications. Let me go a little bit deeper on this. So in 2004, there was a German researcher called Florian Weimer who presented something at a security conference called passive DNS. Out of curiosity in this room, how many of you have heard or know what passive DNS is? One. Okay. So I'm not surprised, okay, but this has to change. So one of the things that became extremely, like in the past 10 years, people have started to understand how much DNS is utilized for criminal activity. There's DGAs, which are digitally generated algorithms to create hundreds of thousands of domain names just used for spam or phishing campaigns, and sometimes they only live for 24 hours, right? And so by actually tracking DNS communications and building a database out of that, you can then have a historical viewpoint, and you can start observing when some nefarious traffic is happening. So this picture shows you what a lot of the passive DNS databases do also, at Farsight we have one. But so basically, if you have a client, a stub resolver, and it's initiating a query, right, you have a recursive DNS server, DNS resolver, and so if it doesn't have the answer in its cache, then it goes through the normal DNS operations, right, to get the right answer to how to get to, at this point I used, the website for nsc.org, and then puts it in its cache so that the second client that tries to get to it, then it just gets the answer from the cache. So what the passive DNS database, the information that it collects only the queries that go, that are the cache misses. So the traffic that goes from the recursive DNS servers to the authoritative and back. And why that is important is because there is no private information then stored in those databases. And so, for databases also to make sure that the entries in there are not spoofed or so, right, you have to look at whether or not they're doing the right thing in terms of validating that, the response is actually from an actual query, and also validating the fields that are actually relevant to ensure that this traffic is more than likely not spoofed. So I won't go through them in detail. There's also bailiwick checking to make sure that for each record name, the response IP address is actually name server for the zone that contains or can contain that name. So, and these are all assurances that the entries that actually go into the database are valid. And so if you look at current DNS statistics, there's about, well, over 278 million current domain names, 100+ million ccTLD domains, and over 10 billion current host names. And so things are constantly in flux, things are constantly changing. And so the questions that can be answered if you're using a passive DNS database are, where did this domain point to in the past? Right? Has the record changed? Well, was it supposed to change, or did the registrar get hacked, right? Or somebody, impersonating you? What domain names are hosted by a given name server? What domain names point into a given IP network? What subdomains exist below a certain domain name? Or what new names are hosted in ccTLDs? And why this is important, right? So this is a user interface that we have. So there's also APIs, there's, you can get streams of data. But this is just for example. So there's a domain name that I had, handy from somewhere. And so I'm like, all right, I want to check out the RR set, right? And for some of you that may not be as familiar with DNS, because, who's an expert in every single protocol, there's different record types. And so I've listed the ones that you can search on, in some environments. There's other ones also, and there's new ones that are getting created. So I just decided to, do an RR set search on this particular domain name, and I happened to hit on, oh, look at that, it's got, quad A records. So there's a IPv6 address associated with it. Now, what's really odd about this, and you might not be able to see it, it's a 2001 DB8 address. Why the heck is that in our database? Right? This is a documentation address, and I should never be seeing anything on this. So just for the fun of it, well, here's, so these are addresses, right, for IPv6 that should never be seen on the global internet. Jen Linkova presented at the IETF, she works for Google. She did a great presentation about how much traffic you actually see on the internet with these source addresses, right? We're terrible at filtering, right? We're terrible at just basic fundamental security across the board, IoT or whatever have you, right? We're not good at that. We have to improve. But anyway, so I just, for the fun of it, took a look at, what else do I see with this documentation address? And I saw quite a few things. Now, some of these things say test in the name, right? So I'm like, oh, okay, well, they, snafu'd in the filter, and nobody in the internet is filtering on this, right? And so it just goes all the way to our database. Yay. Right, so anyway, and I just did this, a day or two ago. So it's fascinating. And at some point, I recognize some of the names in there so I can tell which ISP it might be, but, we'll see. So the interesting thing, right, when we come back to DNS, is that when you have this database, what are the things that are really interesting or could help you as you're trying to figure out, all this communication that's going on with all these devices, all these things, and how do I even try and determine what could be a problem? So one of the things is, any kind of newly observed resource record sets, also, called RR sets. So again, for those of you that may not be as familiar with DNS, a resource record is a single DNS record. For example, an A record, that's an IPv4 address that maps to a fully qualified domain name. Could also be a quad A record, right? That's an IPv6 address. And then a resource record set consists of all the records of a given type for a given domain, right? So the DNSSEC records, the A, the quad A, and what have you. So new entries get written into a DNS changes channel when the new RR name, also called the frequently qualified domain name entry, is written to the newly observed fully qualified domain names channel, or the resource record returned in the response to a query differs from the resource records previously returned from that query. So here's two examples. I was running the channel, and here's kind of the data that we keep. And so it's interesting because, you got the domain name, the time seen, you've got the actual RR name, and then what kind of record it is, and then you can see whether or not the new domain, the new RR name is true or false. And here's a little bit of an explanation for that. The new domain name is the base domain has never been seen before, google.com, right? Of course, that's been seen a zillion times, but for example. Or the new RR name, which is actually the frequently qualified domain. Or new RR type, and this is the new resource record type for this FQDN. So for example, if they didn't have DNSSEC before, right, if we see it for the first time, then it's a new DNS changes entry, and so on and so forth. Oh, and one of the things that I wanted to point out is that if that's too much information, right, some people only want to know when you actually have a newly observed domain name seen, because with all the new TLDs that are out there, right, you may just want to know that, yep, this is the first time I've ever seen it, because you know something, there's no reputation associated with it. And so a lot of domain names are registered just for 24 hours or less, right, and they are used for spam or other nefarious purposes. And this is widespread. You would be surprised at how many domain names are created solely for malicious activity. So, you know, if you only want to look at newly observed domain names, right, that's also something you can do. And, you know, a lot of folks are starting to now look at the functionality of what the layman's call the DNS firewall, which is really the response policy zone, RPZ, right? And in a way, it's creating filter lists in your DNS, so that when your devices, right, if my iPhone is owned, I don't really know, right? But if I'm in my corporate environment and my corporation is actually using RPZ filtering, DNS firewalls, right, and they have lists of domains that are known to be part of malware campaigns and all that, then if my device tries to connect to that site, then the security team will know that, and then they can actually trace back to say, hey, you know something, you're using your mobile device, you know, in our environment when you're allowed to, but you've been owned, you got to fix that. So DNS is a really, really important way to really be able to have control of some of these devices that you otherwise really don't have a lot of control over. And also, you know, detecting phishing scams. So, you know, there's so many phishes out there, right? Spear phishing campaigns, I mean, things that are targeted. I mean, what was in the news, I don't know, 6 to 8 months ago? It was how, you know, all these higher level executives were getting targeted, and, you know, the emails were crafted in a really clever way so that it looked like it came from a trusted person, and they would then transfer huge amounts of money, right? But it was actually a scam. And so usually they also use, you know, some kind of domain name that's, you know, just a little bit different than what you're expecting. And, you know, who has time to really look at the entire domain name of the address, right? You see the person's name and the email follows the style that you think, and you're like, oh, okay, yep, got to do this, right? So, I mean, people are getting really, really clever with their phishing scams. So again, with newly observed domain names and host names, right, you can get some kind of a clue that, you know, maybe something nefarious is going on, and let me dig into this deeper. Something that I've also been a huge proponent on, because I've been doing IPv6 hands-on since 2004. And I have, for years, over a decade, given IPv6 security talks, workshops, and what have you. And, you know, the monitoring tools are not there. Right? I mean, the vendors are waiting for people to ask them for what they need. The customers are waiting for the vendors just to build it, and the standards bodies are going, you know, it's like this never-ending circle. And so one of the things that I also started looking into about a year or so ago is DNS, right? Because if you're already looking at malware campaigns and you know that, you know, these IPv4 addresses associated with it, and then you know these domain names associated with it, well, if the domain names also have Quad A records associated with it, guess what? Right? You can do a bunch of correlation. And so that's also something to really look at. I look at passive DNS as a tool to actually correlate a bunch of different information that, you know, you don't really have the tools for. So in terms of just overall concluding thoughts, right, we all have a role to play to improve on security in this world of continuous and chaotic connectivity. It is chaotic, right? I mean, I look at my Wireshark traces because I'm trying to figure out, ooh, I want to do a screenshot so I can see, you know, what is the Sonos communicating to, what is my television, and I'm like, wow, it will take me 2 hours to sift through this. I don't have that time right now, right? And so really there has to be a better mechanism to figure out, you know, how do we understand who is communicating to whom and why? And really I don't want to know, but I want there to be some kind of transparency. So if I did want to know, I do, you know, I'm aware that things aren't getting sent from my house, like location or what I watch, or without me understanding who's getting that information. Basic security and privacy relies on transparency of information. A friend of mine once said that you never, you know, the day doesn't go by when you don't mention Estonia, and yep, she's actually correct. But I'm proud to be Estonian, and in Estonia, right, I mean, I'm an Estonian citizen as well as US, and they have a government database, right, where they keep track of information. I mean, you can do taxes in 15 minutes. Literally, you log in, you go, yep, 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 done. And the thing that I like is the fact that there is transparency. So I have a mechanism to look and log in and say, who's observed my data? Right, now I have to trust that it's actually accurate, right? But there's, you know, you can go into certain levels of paranoia. I have my healthy paranoia, but I do know how to stop, sort of. But yeah, but right, I mean, I have at least some trust, okay, pretty decent trust, that at least I know that that entity looked at my credentials or my information, and I can see like why, right? Or yeah, maybe it makes sense because, you know, it was the people from the taxes, or, you know, the bank was doing an audit, or who knows what. But transparency is key because transparency also builds trust. You know, the bugs, they keep on happening, right? We're human. I used to write code at one point. The last time I wrote code was my FDDI thesis. And then I said, nope, because I'll never see the light of day. Then I started with networking. Also don't see the light of day. However, you know, but software bugs, configuration mishaps, and protocol errors will always be there. We will have to get better. I mean, one of my pet peeves is that I remember that, you know, I got an A for programming, but, you know, there was never any error checking. And so what causes a lot of the bugs? Corner cases, right? You just get it out the door. We don't even teach error checking in this day, right? It's not, you know, this is not good. So, I mean, but when people were worried about, oh my gosh, you know, this glibc issue, yep, another one, right? I mean, you have to just be aware that Internet of Things, we're gonna need to upgrade, right? Even though I don't know exactly what my light bulbs are upgrading all the time, I'm still, when I saw that in October 2014, I can almost 95% guarantee you it had to do with Heartbleed, because I do see that they use TLS, right? And so, you know, that's a good thing. So when people say that, yeah, none of these things do it, they do, but they, you know, just has to improve. And, you know, let's do pay attention to DNS because it's almost ubiquitously utilized and can be utilized to detect anomalous behavior. And that's it.
Thank you very much, Merike Kaeo. I think Merike is giving us a very unique perspective at looking at security. So I'm sure there must be some questions from the audience. You're welcome. And also I'm going to ask the audience to start walking towards the microphone so we can save time if you have a question. The microphones that are standing right here.
I was curious about the, you talk about there's a lot of these quick registrations, and I was curious about the administrative mechanism by which domains are registered and then somehow discontinued after 24 hours. How are they getting them and how are they ending them within that time period?
You can buy a domain, right? I mean, it's very easy. If you have the money and it makes sense to you, you can just register it and you can just not use it, right? Or, Yeah, I'm actually also on the Security Advisory Council for ICANN. And so these are the kinds of issues that we're also looking at in terms of, how do you deal with this kind of behavior? And can you detect that? And if registrars are aware of that, right, how can you actually stop that kind of behavior? So there's work in progress on that. And also know that one of the nice things in terms of domains is with the places like the anti-phishing group. And so there's been over a decade worth of work globally to actually, once you identify that domains are used for nefarious behavior, to be able to actually do takedowns.
But it's not that they're getting disconnected after 24 hours, they're just going dormant after 24 hours? They have a spike of use within the first 24 hours and then they're going quiet, and that's...
They're just not being utilized, yes. I mean, they still exist in the DNS system, right, because it all depends on how long the time to live timers are and whether or not these records get propagated. But basically, if I'm registering a domain and I'm doing a spam campaign, right, then I'll utilize that domain as the source address of my spam campaign, and then after 24 hours, I don't utilize it anymore. And then there's a registry period where they can just time out.
Next question.
Yeah, I really loved your presentation, especially because it really directly answered a couple of the questions that we posed in the paper. So this is really great. So in terms of identifying anomalous behavior and some of the techniques that you've kind of done on the side, what would it take to package that up into something that could be in the marketplace and be more widely used?
So I work for a company that does this. So yeah, and so there's multiple companies that have some of these databases, passive DNS databases. And so there's continued efforts to actually raise the awareness of how you can utilize them, and then also working with what are some of the other problems, right, to then do more correlation, right? Because if you do correlation between, let's say, DNS, between routing, right, between email spam issues, right? And so this is all works in progress from the overall community, if you will.
So then how does it get down to the hands of people who actually own and operate these systems on sort of a broader, more commercial basis? The people who have the televisions and the refrigerators and...
I think there's conversations to be had,
yeah,
right? Because one of the things that was unclear to me was where is DNS utilized for across all of these, protocols. I mean, I was looking at Zigbee real quick, and I'm like, okay, yeah, they do TCP/IP and all that. But some of the other, like from the electric, vendors, and I mean, if you're talking about naming, are you using some other naming scheme where if you're actually using the IP protocol, can you revert to actually utilizing DNS? And is that a unifying factor that we want to strive for? I don't know the answer to that, but that is something that I would like to see happen, right? Because, I mean, I think what we need to do is a consolidation of all the things that people have standardized, right? And the problem is that we have so many standards now, we don't know which one to choose. Right? And so rather, to your point before, rather than creating a new one, let's look at the ones that exist, and then let's look at what are the fundamental requirements that we need for most devices, and what can we create a unifying, ground layer.
Okay, great. Any other questions? See, there's one question. That will be the last question.
I can't echo your concerns about an unfriendly actor device inside your network. I've, on the farm, installed a number of cameras, inexpensive, from China, with dynamic IP reroutes already built in and authenticated to I don't know who, with sound, with imagery, and I don't know what else. The question is, I so much agree that we should know who's looking and where that data is going and how it's being used. the politics of that are daunting, especially since there's so much money in the harvesting of that data and using it. I've heard internet bills of rights. I've seen many versions of it, but what it would take to get there, industry public shaming, maybe, for bad actors that don't comply to transparency. What would it take to make it a right to know?
So in the past probably decade and a half, I've traversed the globe I don't know how many times, especially when I was kind of on my own and consulting and wanting to be global in all aspects of security. I am not a proponent of naming and shaming. I just am not. Maybe it's just my inherent personality. I do believe that we are nowhere near done with education. And when I hear people saying that we've educated for 10 years, I sit there and say that, maybe how we teach is wrong. And maybe we should also be listening to some of these, users or developers of devices to see what are their problems, right? And then how can we come to a common ground? And I was a keynote at the South Asian Network Operators Group meeting 2 weeks ago. And I loved it. I used to, do workshops there, 10 years ago, and it was wonderful to be back. And the regulator there spoke, and he was wonderful. He said, here in Nepal, here's in Southeast Asian region, right? I mean, we have different problems. If you have technology and you want to innovate and it's not regulated, build it, we will catch up. I loved it, right? And when I look at the global problems in terms of transparency, I think a lot of times when I see devices, and I happen to sometimes be able to talk to some of the engineers, they just didn't know, right? And we think, oh, we're all in the same circles. I mean, I could say, wow, really? You guys don't know about passive DNS? Are you kidding me? We've been talking about this for 12 years, right? But this is not the right circle, even though we're all members of the Internet Society. And so I think, we are in our infancy to really try and figure out what are the fundamental requirements that these devices need to do and need to have. Because, people have been innovative. It's been awesome, right? But it hasn't been structured, which is okay. We'll get there. And so I don't have an answer for you. But I'm a huge proponent of let's keep educating.
Thank you very much, Merike Kaeo.
Thank you.
Really great discussion.